All right, so we've got a little bit of probability going on here. And we're going to talk about a couple different topics. None of this is really difficult, but it is stuff that you all need to know about. So, first of all, when we talk about probability and we mention the phrase or the term independent events, this is talking about two or more events that occur and do not affect each other, right? So we'll talk about some examples here, but you can already see on my screen here. One example might be we flip a coin and we roll a dice, right? I can flip the coin as many times as I want and it does not affect what's going to happen to the dice, and vice versa. The dice rolling does not affect the coin, right? I can pick a number and you can pick a number, and we don't affect the number that the other person picks. Those are independent events, right? It becomes different. We can, later on in probability, not in grade 7, but in further grades, you will learn about where you get more events that depend on each other, right? So it could be I pick one card from a deck and I keep it, and then I pick another card. Obviously, I cannot pick the same card twice. And so the probability changes each time. But in this case, when we have independent events, the probability for one does not affect the probability of the other, right? And secondly, another word we should make sure we understand is this term here, sample space. Now, sample space is a weird way, but it's a probability theory word, or term, I guess I should say. But this is a weird way of describing the list of all possible outcomes of a probability experiment. All right, so real simple, I roll a dice. It's a 6-sided die. My sample space would be a 1, a 2, a 3, a 4, a 5, or a 6. That's my sample space. All right. Obviously, when we get to have a few more events going on all at the same time, so when we get down here to example number 1, then obviously we have to talk a little bit more about how do we show the complete sample space. All right, so let's take a look here. Coin is flipped, 6-sided die is rolled. These two events are called independent events. Lovely. Here, first let's use a table to list all the possible outcomes. So, if the coin is a head, the die could be a 1, 2, 3, 4, 5, or 6. Right? So we could have a head and a 1. We could have a head and a 2. You're going to have fun watching me write all these H's. We could have a head and a 3. We could have a head, you got it, and a 4. We could have a head and a 5. We could have a head and a 6. We could also have a tail and a 1. We could have a tail and a 2. We could have a tail and a 3. A tail and a 4. A tail and a 5. Or a tail and a 6. How many possible outcomes are there? Well, we could count them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes. All right. Which then takes us on to the next bit. Write the sample space for this combination of events. So I'm going to actually just type this because that's easier. But the sample space is basically taking what's in the table and plopping it down here. But I'd say H1, H2, H3, H4, H5, and H6, T1, T2, T3, T4, T5, and T6. So again, there were 12 possible outcomes. Sample space means I list all of those outcomes. Okay, and you might think, okay, this seems sort of silly. I just listed them all in the table. It is sort of silly if you've already done them in a table, because a table is a way of showing that sample space. However, if we move on here, when we want to represent some outcomes with a tree diagram, a tree diagram, pretty easy. It makes it make a little bit more sense sometimes to show your sample space, because sometimes a tree diagram, if we have a complicated series of events, is harder to interpret, and so having the sample space written out makes it easier. However, that being said, a tree diagram, if we have a more complicated setup, works really, really nicely, much better than a table. Okay, in this case, it's pretty simple either way. So let's take a look. Create a tree diagram here. So we've got a coin flipped and a spinner is spun once. So let's talk about the coin flip, because that's the easy one to start with. Coin flip. It could be a head or it could be a tail. So we list, and it doesn't matter the order we do this in, right? I could start with the spinner. I can show that afterwards here. You only need to write down one of them, but I will show both of them just to show you that the outcomes it lists are the same. So after the head or the tail is flipped, then we're going to have a bear, a salmon, or an elk. And I'm just going to use a B for a bear, an E for an elk, or an S for a salmon. So a head could be followed by, we spin a bear. Don't actually try to spin bears, because that's going to end badly for everybody involved. If you have a bear on a merry-go-round, just leave it alone. Sorry. Here we go. So we could have a head, a bear, head, elk, head, salmon. We could have tail. And there's 3 options here as well. Tail and then a bear. Tail and then an elk. We could have a tail and then a salmon. All right. Now, if I'm going to list the sample space here, I have to be really careful. I'm going to, and this is hard for me just the way my program works here. I will write these out because there's only 6 of them. Head, bear, comma, head, elk, comma, head, salmon, comma, tail, bear. That's supposed to be a comma there. It sort of doesn't look like one. Tail, bear, comma, tail, elk, comma, tail, salmon. All right, there's my sample space. Now, I'm going to erase all of this real quick, and I'm going to show writing out the tree diagram the other way, showing the bear, elk, salmon thing first. So here goes. I could also have written my tree diagram in this way, where we have the 3 options to start with. I could have a bear, I could have an elk, I could have a salmon. And if I have a bear, I could flip a head or a tail. If I have an elk, I can also flip a head or a tail. If I have a salmon, I could flip a head or a tail. And you could prove this here. The sample space is the same, right? I could have a HB, you should have this down, HE, HS, TB, TE, and TS. All right? Which takes you to your assignment. It'll be on the page that's handed out to you. Thanks.